In this lecture, we'll study from question number 158 to 164. Okay, so just go through the lecture, and if you have any doubts, mention in the comment section, and that's it. In mathematics, there is a chapter called AP, GP, and HP. Okay, this question uses the concept of geometrical progression. This is a concept of mathematics that says that if there are numbers, okay, in a pattern such that 1 by x to the power 0, or let's say a by x to the power 0 plus a by x to the power 1 plus a by x to the power 2 plus a by x to the power 3, and so on. Okay, as long as a by x is lesser than 1. Okay, a by x to the power, these values should be lesser than 1. That means these values are not greater than, lesser than 1. All of these values are lesser than 1. Okay, a by x to the power 0 is also lesser than 1, lesser than equals to 1. Okay, plus a by x to the power 1 is also lesser than 1. Okay, then if you add this series up till infinity, the sum of this series is given by a by 1 minus 1 by x. Understood this one? Acha. This can be said as, see, out here a can be given as some value, say 1, 2, 3, 4. X can be given as any integer value, 2, 3, 4, 5. Okay, and the summation of this entire value up till infinity is nothing but a divided by 1 minus x. Now let's read the question. In this question, okay, there is some ground out here and a ball is at height h. Now the ball bounces off the ground, but after bouncing off, it is a kind of inelastic collision. That means after bouncing off, the velocity reduces by 1.25 times. That means after coming down, this ball came down. Okay, so what is the velocity of this ball coming down? Velocity of this ball coming down is nothing but under root of 2gh. If you apply v square is equals to u square plus 2as, you get velocity while coming down is equals to under root 2gh. Then again it will go up. Okay, it will go up with, after bouncing, it will go up with how much? Let's see. After bouncing, it will go up with how much velocity? Under root of 2gh by n. So under root of 2gh by n, because the velocity reduces by n times. Okay, so again it went up and it came down. Okay, it will come down with same velocity, no? So I'm showing this as a 2D motion, but it will go up, and come down with same velocity. Okay, after the third strike, the velocity would become 2gh divided by n square, because out here the velocity would be reduced by n times from this velocity. After the fourth jump, the velocity of the ball would be in upward direction would be, or velocity of the ball after jumping would be under root of 2gh by n cube. The question is asking the ball jumps up till infinity, meaning infinite number of times. Okay, what is the total momentum of the ball that impulses to the slab after numerous bounces? That means after infinite bounces. Okay, so out here we have to apply change in momentum of the ball. Change in momentum after of the ball is what? Final momentum minus initial momentum. So let's see the first bounce. This ball dropped. Okay, after first bounce, what will happen? Final momentum is this one. Okay, it will go up, and initial momentum is this one, no? So final momentum minus initial momentum under root 2gh by n divided by minus 2gh. I made a mistake out here. Okay, can you figure out what is the mistake? While dealing with momentum or any vector quantities, always assign a coordinate system. So if upward is positive, downward is negative. So minus final momentum minus of initial momentum. So there would be initial momentum has a minus sign along with it, no? And this minus would become plus. So out here plus. Similarly, for second bounce, the ball will go up with this velocity, come down with the same velocity, and again go up with this velocity. Okay. So for second bounce, what is the change in momentum? Change in momentum is nothing but final momentum under root of 2gh by n square minus under root of 2gh by n under root of plus of 2gh by n. Similarly, after the third bounce, it would be under root of 2gh by n cube plus under root of 2gh by n square. Okay, and so on, both bounds and so on. So if we rearrange this equation, what will happen? See, I'm just rearranging this equation. Okay, change in momentum is equals to, take under root 2gh out here, under root 2gh. This 2gh by n appeared two times, first time, second time. So plus under root of 2gh by n, 2 into 2gh by n. Why? Because it appears two times. Similarly, n square will also appear two times. So plus 2 into under root of 2gh by n square plus 2 into under root of 2gh by n cube for third bounce, and so on. So this is the pattern up till infinity. This is the pattern up till infinity. Okay. Now this pattern is nothing but we use the concept of this one. Okay. So if you take under root of 2gh common, under root 2gh common out here, it would be 1 plus 2 by n plus 2 by n square. Okay. Plus 2 by n cube up till infinity. Now simply you can see one more thing. See out here, if there was instead of 1 we got 2, the value of a would be equals to 2, no? But the 1 disturbed out here. Okay, we can simply write 1 as, see, I can simply write plus minus 1 plus 1 minus 1 out here, and this one can be added to this one. Okay, see, within a bracket what I'm doing is I'm closing this within a bracket. Okay, okay, now I can write plus minus 1 out here, plus 1 minus 1. Okay, so this one and this one will get added to become 2. So this one and this one becomes added to 2. Okay, now see, I got this progression. Okay, instead of x I'll use n. So a by, see, this is nothing but 2. I can use this as 2 by n to the power 0. 2 by n to the power 0 plus 2 by n to the power n plus 2 by n square, and so on. So the summation will be nothing but, see, if I do out here, change in momentum is equals to under root of 2gh into, what is the value of a? The value of a is 2 divided by 1 minus 1 by n minus 1. Okay. Now this is the answer. Okay. Just simplify the equation out here. See, if I take n common, it would be this value n minus 1 by n. Now if I take this n upward, it would be 2n. Okay, 2n, and this value would get. Now if I take n minus 1 as LCM, okay, and subtract in 1 out here, what would it would be this value. Okay, and this entire value is nothing but n plus 1. 2n minus n is nothing, n, and minus gets plus. So this is nothing but n plus 1. N plus 1 divided by n minus 1. Now one more important concept to discuss out here in physics. Okay, the term is called coefficient of restitution. Coefficient of restitution. This is used in collision. Coefficient of restitution is given by E. E is nothing but velocity of separation divided by velocity of approach. Okay, velocity of separation divided by velocity of approach. Velocity of approach. Okay, in perfectly elastic collision, E is equals to 1. In imperfect collision, E is lesser than 1. Okay, and purely imperfect collision, E is equals to 0. Out here the value of N. Okay, out here N is nothing but 1 by E. See, if you observe closely, N is nothing but 1 by E, or coefficient of restitution. In your syllabus, okay, in the JEE syllabus, instead of using N, you will most probably use E, or E is nothing but coefficient of restitution. So they can rotate the question by giving E is equals to 0.8. This is the same question. Understood? Now this question uses the concept of conservation of mass. Okay, not conservation of mass, conservation of momentum, center of mass. See the question, what the question actually says. See, there is a boat or a plank of mass m and there is a human of mass small m. Okay, the length of the plank is L. Now they are motionless. Okay, motionless means neither of them is moving. So if neither of them is moving, what is the displacement of center of mass? Okay, suppose I see from out here. Okay, what is the velocity of the center of mass if neither of them are moving? The velocity of the center of mass is equals to 0. So displacement of the entire mass, or displacement of the center of mass, should be equals to 0, no? So displacement of center of mass should be equals to 0. How? M into 0 plus m into 0 divided by m plus m. So it doesn't matter. Okay, which is equals to 0. So since there is no velocity of the system, okay, the displacement of center of mass is equals to 0. Now, now the person out here, okay, reached by distance L. That means person out here moved across the boat. The question is asking if the person moved across the boat and this surface was frictionless, the boat or this plank must also move in this direction. Okay, what is the amount this boat moved in this direction? Okay, I'm changing my frame of reference. That means this person will see this boat move in this direction because this person moved in rightward direction, no? Okay, if this person walks along rightward direction, this plank should move along leftward direction. Okay, so if this person cross the plank, what is the displacement of this plank in leftward direction? See, let the displacement of this plank in leftward direction be x, okay, or L given in the question. Okay, not L, x. If you use L, it will be very disturbing. X. Now see, this person moved the distance L. This person moved rightward with distance L, no? But distance L relative to whom? Relative to the plank. That means a person sitting out here would see this person move little bit lesser than distance L. See, as the person is moving rightward, the plank is also moving leftward, no? So a person sitting on the ground will see his total displacement little bit lesser than L, and that is the value that I must found. What is the, sorry, that is the value I must take out here while conserving the center of mass. Okay, so the displacement traveled by this mass m is L, but according to the frame of reference of this plank. Okay, now if I change my frame of reference to the ground, what will happen? I must add this velocity, and this velocity is in opposite direction. So the total displacement as seen by someone on the ground is nothing but L minus x in this direction, because it should be little bit lower than L. Okay, I can simply conserve center of mass out here. Since there is no external velocity of the system, there is no external velocity of the system, displacement of center of mass is equals to 0. So displacement of center of mass is nothing but m. See, if this side is positive, this side should be negative. That's why I have added minus out here. Okay, so m into minus x plus small m into how much? L minus x. L minus x divided by capital M plus small m. This should be equals to 0 because there is no external velocity of the system. Now if you just solve this equation, no, the value of L would come out. The value of x would come out. Not L, I'm trying to find out x. Okay. So the displacement of the boat is given by this value. Now the second part of the question is asking, see, I've changed a variable a little bit. Instead of using x, see, I've used x out here, okay, and L out here instead of dash. This entire thing is L. So do not get confused out here. Okay. Now, the second part of the question is asking, what is the horizontal component of force with which the man acted? Okay. So part B of the question is not that much important, but again we'll do it. Force is nothing but dp by dt. Okay, dp by dt, and we're analyzing the force on the raft. No, what is p? P is nothing but product of mass and velocity. So d into mv by dt. Okay, d into mv by dt. Why capital M? Because we are analyzing this body. Okay, this mass is constant m dv by dt. Now see. Now in order to find out the velocity, see, this person went rightward with the velocity v given in the question. Okay, this was the velocity. Okay, out here instead of using v dash, I'll use v. Okay, so the raft would also move backward with some velocity. No, let that velocity be u. Similarly, if you use the same concept, okay, velocity of center of mass is equals to 0. So what is the initial velocity? And the entire system was not moving. Okay, so in the wrong diagram I have written v. The person moved with velocity v. Okay, and this v is relative to the raft. If we change this v relative to the ground, what will happen? V minus u. Understood? Okay, now similarly we apply the same concept. Velocity of center of mass is equals to 0, or mass into minus u plus small mass into v minus u should be equals to 0. Okay, divided by m plus m should be equals to 0. It doesn't matter if you take m plus m or not. You can simply multiply it by 0. Okay. So out here, if we solve it, u is equals to mv by m plus m. That means the velocity of the boat would be mass of the man into velocity of the person according to the boat. Okay, as observed by the boat, divided by m plus m. Okay. Now simply if we apply this velocity out here, okay, what is the velocity? Velocity is nothing but, or velocity of boat is nothing but mv by m plus m. Okay, out here small m, capital M, and this is constant, so you can separate them out. So our change in velocity would be m by m plus m into dv by dt. Okay, so this is the force exerted by the man on the, sorry, exerted on the plank. Understood? In this question, what happened is, say out here, okay, a mass was there, okay, and a ladder and a person was there. The combined mass of ladder and the person is capital M. That means this mass was balanced by this combination. Okay. Now what happened is, from the starting, see, you see from the starting, the person started climbing on the ladder. So if the person started climbing on the ladder, what will happen? The ladder will go down. If the ladder goes down, the mass will come up. Okay. If the length of the ladder is L dash and the person climbed from the bottom of the ladder to top of the ladder, okay, the question is asking, find the displacement of the human, okay, from the frame of reference of ground. See, one thing, this mass and this ladder is connected by a string, so this should be in a constant motion, no? That means the amount this block went up should be exactly equal to the amount the ladder came down. So suppose the block went up by L distance. That ladder will also come down by L distance because the length of the string will remain constant. Okay, now see, the person climbed from this position to this position, isn't it? See the video once again. The person climbed from this position to bottom of the ladder to top of the ladder. So the displacement of the person in upward direction is L dash. But this displacement of L dash is seen from the frame of reference of ladder, no? That means from the frame of reference of ladder, he climbed up L distance. But from someone from the ground, what will he see? He went up L distance and the ladder also came down L distance, no? So the total displacement is nothing but displacement of the person plus displacement of the frame. So total displacement of the person according to this frame is nothing but L dash minus L. Now the question is asking find the total rise of center of mass of the system. That means if we consider this block, this ladder and this person as a system, find the total rise of center of mass. So a rise of center of mass is nothing but mass of block, okay, into rise of block. And while dealing with center of mass or velocity acceleration, and not center of mass, while dealing with velocity acceleration and displacement, always assign a coordinate system. So mass of block move in positive L direction from the frame of reference of ground plus mass of ladder. What is the mass of ladder? If the mass of ladder plus human is capital M and given in the question the mass of human is only small m. So what is the mass of ladder? Mass of ladder is nothing but mass of the entire system minus mass of human. This is the mass of the ladder into what is the displacement of ladder minus L plus mass of human into what is the displacement of human L dash minus L. See, while applying this formula for center of mass, okay, always take your displacement, velocity or acceleration from the same frame of reference. Okay, if I did only L dash out here, it would be error because L dash, the displacement of L dash is from the frame of reference of ladder. I have to write the displacement from the frame of reference of ground. Now divided by total mass. What is the total mass? Mass of block plus mass of ladder plus mass of human. Okay, now see, the same will get cancelled. Okay, out here. If I have, if you calculate m into L and minus m into L will get cancelled. The same and the same would be minus ml. So this ml, this minus L got cancelled. Okay, one more thing. This minus ml into minus ml would become plus ml, and out here m and m minus L would become minus ml. So this value and this value would get cancelled. So m and L. Okay, since both the values are cancelled, I'll just cross out this L also. L. So our rise of center of mass is nothing but the remaining values are m, L dash or length of the ladder divided by 2m. Okay, if we add in the denominator, we'll get 2m. Okay, and this rise of center of mass is from the frame of reference of ground. Simple enough. In this question, what happens is cannon is sliding down, and after sliding down, it fires a projectile with velocity v. Okay, now see, the question is asking determine the duration of the shot. That means after firing the projectile, the cannon comes to stop. Okay, and why does it come to stop? Because the shell imparted some momentum in the opposite direction. No, so look out here. Okay, look in this question. Out here, just before the shell has been ejected. Okay, this cannon plus shell came from out here to out here. No, so what was the velocity? The velocity of the cannon plus shell in this direction is nothing but v. Okay, v naught. Okay, and what is this v naught? If I apply v square is equals to, or v naught square is equals to u square plus 2as, let the length be L, where L is the distance the cannon plus ball traveled. It started from zero velocity out here, so initial velocity is equals to 0. Okay, see, while the cannon is sliding, The only force acting on it is gravitational force in this direction, which is equals to mg sine alpha in this direction. So the acceleration due to gravity would be g sine alpha, g sine alpha, and s is equals to nothing but L. So out here, V naught is equals to under root of 2gl sine alpha. Okay, so the velocity of the cannon plus shell just before the shell has been ejected with horizontal velocity v, okay, is nothing but under root of 2gl sine alpha. Now see, now the shell has been ejected, no? Shell has been thrown with some velocity along the horizontal. So after the shell has been thrown, okay, some momentum has been imparted on the shell, isn't it? So if some momentum has been imparted on the shell in this direction, equal and opposite momentum will be imparted on the cannon on this direction. Okay, so let's say momentum imparted on the shell is nothing but p in this direction. Okay, which is equals to mass of the shell in and velocity. Okay, equal and opposite momentum will be directed or applied on the cannon on the opposite direction in this direction. Okay, and since we are dealing with inclined plane, we always have to take component along the incline and perpendicular to the incline. What is the component along the incline? What is the component of this momentum, equal and opposite momentum along the incline? It is nothing but p cos alpha, isn't it? P cos alpha, p cos alpha. Okay, now I have to find out what was this velocity v. Now say this change in momentum that has been applied on the cannon, okay, is nothing but impulse. Impulse is what? Force into dt, no? And we have to find out the dt. Okay, so if I write f dt, or force into dt, or force is equals to change in momentum by time, or if this change in momentum is large enough, okay, delta p by delta t. Okay, see, out here in this equation I have to find out the time. Okay, time for which this force acted on the body, or the impulsive force acted on the body. So delta t is equals to delta p by f. Okay, this is the value I have to find. Now delta p, delta p is nothing but change in momentum, no? What is the final momentum? Final momentum was nothing but mass of the cannon into v naught, or delta p is nothing but mass of the cannon or final momentum. Let me elaborate this one. Okay, which is equals to final momentum minus initial momentum divided by force. Acha. Final momentum is nothing but how much? Acha. Final momentum of the system is zero. Okay, just before, just after collision, the cannon comes to stop, no? So it is nothing but zero. Okay, what is the initial momentum? Initial momentum was nothing but this value minus this value, or initial momentum is m mass of the cannon into v naught. What is the value of v naught? Under root of 2gl sine alpha. Under root of 2gl sine alpha minus of what is the momentum induced in opposite direction? P cos alpha. P cos alpha. And what is the only force acting on this body? The only force acting body on this body is nothing but mg sine alpha, or mg sine alpha. Now some of you might have questioned, why have I done forces mg sine alpha? See, the momentum imparted by the ball, okay, should be sufficient enough to stop the cannon, no? This momentum can be much larger, okay? If it was much larger, what would happen? The cannon would go up, or the time taken to come to stop should be much lesser in value, okay? So the minimum value of momentum that should be imparted in this direction should counteract the work done by this gravity force, no? What would the should counteract the gravity forces out here? and the gravity forces out here is nothing but mg sine alpha. Okay, so out here delta t is nothing but 0 minus of this is nothing but p cos alpha, p cos alpha minus m into under root of 2gl sin alpha divided by mg sin alpha, mg sin alpha, and capital M, capital M, capital M G sin alpha. Okay, see what happens in this question is a ball of mass m, okay, strikes this plank of mass m with velocity, some velocity, and after that what happens is the mass gets dislodged in the block and the block swings by certain degree, okay, by certain angle theta. The first part of the question is asking the velocity of the bullet before striking the body. That means the ball or the velocity of this ball that is given in the question. Acha. So in order to solve this question, I have to apply work energy theorem. But how do I apply it? See, after this ball strike this entire plank system, this entire system went up by angle 30, no? And what is the length of the string? The length of the string is L out here. Okay, and the length of the string never gets compressed, and the length of the string out here is also L. So what is the height the block reached, or what is the height the block plus bullet system went up? Okay, okay, the block went up from certain height, no, the block went up to certain height. So what is this much height the block went up to? Is nothing but L minus L cos theta. So this height h is nothing but L minus L cos theta. L minus L cos theta, that can be written as L into 1 minus cos theta. Okay, so we have found out the height. Now let's say after the bullet has been lodged inside the this frame or inside this plank, the let's say the velocity of the entire system becomes v1. Okay, so can I apply work energy theorem? If I apply work energy theorem, what is the final velocity of the system out here? 0, because it will come down to entire stop after coming out here, no? So 0 minus what was the entire velocity of the system after the bullet was lost? After the bullet was lost, the entire velocity of the system was assumed to be v1 minus half m mass of the plank plus mass of the bullet into v1 is equals to what are the forces doing work out here? See, there are two forces. One is the tension force and another is the ng force. The tension force won't be doing any work because see, I assume this h to be very small and this theta to be very less. Can I assume this to be a circular motion? Because the length is always constant, no? And if you trace out the path, it is always circular motion. Okay. If the length remains constant, okay, and the angle only varies, it is supposed to be circular, no? Okay. So in circular motion, the displacement is always perpendicular to the normal force. Okay. So work done by tension force out here is equals to 0. So the only work doing out here is gravity work. The work done by gravity is mass of the system into g into h, where h can be replaced by L into 1 minus cos theta. So h is replaced by L into 1 minus cos theta. Now what I do out here is I solve this problem for velocity v1. Out here, minus and minus will get cut, m plus m and m plus m will get cut. Okay, v1 would be equals to v1 is equals to 2 gl 1 minus cos theta. Okay, acha, half m v1 square. v1 square is equals to 2gl 1 minus cos theta. Acha. Now I found out the velocity of the system just before the plank started going up, but I have to find out the velocity of the ball. So can I say the momentum is always conserved? See, the momentum of the system before collision and after collision, just before the entire system started going up, is constant because no external force is acting on the system. I'm considering this ball and this plank as a system, no? So before collision, what is the momentum of the system? Half, no, momentum is nothing but mass into velocity. So mass of the bullet into velocity of the bullet plus mass of the plank into velocity of the plank was 0. Before collision, before the bullet collided with the plank, the velocity of the plank was 0, no? Now after collision, the entire system started to move with v1. So it is nothing but m plus m into v1. Now can I substitute v1 from in this equation? Of course I can. So let me substitute v1. Okay, v1 is nothing but under root of 2gl1 minus cos theta. Okay, now momentum before collision and momentum after collision are same because no external force is acting on the system. So let's equate them both. Mv is equals to m plus m into under root of 2gl1 minus cos theta. Okay, and v is equals to, see, if I send this m down here, v is equals to how much? This value. Okay, so the velocity of the bullet just after collision is nothing but capital M plus small m divided by m into this value. Okay, now in the question there is a very important assumption out here. The assumption is the mass of the bullet is much lesser than mass of the plank. So out here the assumption is meaning that out here you have to assume mass is equals to nearly 0. Now you might have question, sir, why haven't you done denominator mass is equals to 0? So whenever such assumptions are given, okay, m is lesser than m, always apply those assumption in addition or subtraction, never in multiplication or division. Okay, in your entire syllabus of physics, whenever such assumptions are given, okay, always apply those assumption in addition or subtraction, never in multiplication or division. Okay, so out here what do we get the velocity? We got the velocity as capital M by small m into under root of 2gl1 minus cos theta. Fair and fine. What is the second part of the question? The fraction of the bullet's initial kinetic energy that turned into heat. Okay, so how do I find out the percent of kinetic energy that converted into heat? See, out here this kind of collisions are called inelastic collisions. Okay, and in elastic collision kinetic energy is not conserved, so the loss of kinetic energy is nothing but the energy that has been converted into heat, isn't it? Okay, so final kinetic energy minus initial kinetic energy. I'm not considering the final kinetic energy out here. If you consider the final kinetic energy out here, you can do that, but out here you have to subtract the work done by gravity. Okay, so if you consider final kinetic energy after collision minus kinetic energy before collision is equals to percentage of kinetic energy that got converted into heat. Okay, so before collision, what was the kinetic energy of the system? Kinetic energy of the system was nothing but half mv square, or mass of the bullet, into velocity square. Plus, does this plank contain any kinetic energy before collision? No. So the kinetic energy of the plank before collision was 0. After collision, okay, what is the kinetic energy of the body or entire system? Half m plus m. The entire system moves with same velocity, no? Into v1 square. Okay, understood? And the percentage of energy that got converted into heat is nothing but difference between this one, not percentage. The amount of energy that got converted into heat is nothing but kinetic energy after collision minus kinetic energy before collision. Okay, so heat energy heat energy is nothing but final kinetic energy minus initial kinetic energy. So half m plus m into v1 square minus half mv square. Okay, understood? So this percent of energy got converted into heat. And one more thing, do you know how it got converted into energy, heat energy? The friction force. So this is nothing but the work done by friction force that got converted into heat. Okay. Now the question is asking the fraction of bullet's initial kinetic energy. That means this is the actual heat energy, no? How do I convert this percent, or how do I find out this percent in terms of percent? So this is the heat energy divided by initial kinetic energy. Okay, or let me write down heat energy in percentage. In percentage. Percentage, not percentage, in fraction. No, percentage you have to multiply by 100 in fraction. So it is nothing but heat energy m plus m v1 square minus half mv square divided by initial kinetic energy. Okay, so this is the fraction of energy that converted into heat. Now what I have to do out here, I have to replace v1 from out here. Okay, v1 from out here, v from out here. Okay, and find out the fraction. So we have to solve this equation to find out the value of heat energy lost in terms of percentage. So what do we do? I simply divide. Okay, or heat energy in terms of percent is equals to, see, I can cut out the half, I can take half common. I am dividing the entire equation by mv square, by the denominator term. Okay, so m plus m into v1 square divided by mv square. Okay, if I divide by mv square, it would be minus 1. So minus 1, and the denominator is the only thing I'm dividing it by, no? So it will become this value. Now see, now if I just, okay, what do I do? Now if I just take v1 by v square, okay, this v1 square by v square, or v1 square by v square. So v1 square is nothing but v1 square by v square is nothing but 2gl 1 minus cos theta divided by v square. V square is nothing but m by m whole square into 2gl 1 minus cos theta 1 minus cos theta. So 2gl 1 minus cos theta and 2gl 1 minus cos theta would get cancelled. So v square by v square is nothing but small m by capital M whole square. So small m by capital M whole square. So I'll just substitute this out here, okay? Or which is equals to m plus m by m into v1 by v square is nothing but m by capital M whole square minus 1, okay? Or m plus m divided by m into m square by m square minus 1. This square and this m would get cancelled, okay? It would be nothing but, see, I have to multiply this m, no? So m plus m square minus m square by m square. Okay, what I have done out here is I have taken this as LCM, okay, and proceeded to find out the entire value out here. Okay, so out here what we get is, Asha, can I ignore the small m out here, m square? Can I ignore this m square? Because m is much smaller than capital M. Okay, and this is in addition. Can I ignore it out here? No. Why? Because it is in multiply with capital M, multiplication with capital M. Okay, so I can ignore this m square to 0. So it would be m minus m square divided by m square. Or if I take m common, m minus m divided by m square. Square and square m would get cancelled, or the percent of energy lost would be m minus m divided by m. Okay, now this would be coming in negative because m is much smaller than m. Okay, and I have done out here, see, this kinetic energy is much lesser than this kinetic energy, no? So that's why the negative is coming out here. Half mv square. This was the kinetic energy of the bullet, and this was the kinetic energy of the collision after kinetic energy of the system after collision. So this will be much lesser than this one, no? Okay. So that's why this negative is coming out here. That means negative out here means energy is being or heat is being generated. That means the final kinetic energy is lesser than the initial kinetic energy. So if I take modulus or percent of heat energy, percent of heat energy is nothing but capital M minus small m by m. Understood? Just reverse this half mv square minus this one. You would get capital M minus small m by capital M. Okay. Dealing with equation is the fundamental way of solving or going through problems. See, in this question, this surface is frictionless, this entire surface is frictionless. Okay, and initially this block was given a velocity v. Okay, after some time, what will happen? This block will rise up. Okay, the question is asking find the maximum height the block has risen up. Okay, so when the block was out here, somewhere around here, okay, the block was somewhere around here. Okay, going up with certain velocity, let's say vy. Okay, out here it did not reach the maximum height. Okay, it will reach the maximum height after some time. Okay, see, can I apply conservation of momentum out here in this entire system? Okay, initially, okay, what is the momentum of the system? M into v plus capital M into 0. Okay, finally, okay, when the block reached out here, okay, still going up with certain velocity vy. What is the momentum of the system? See, this block and this mass, okay, will remain together, no? There is nothing to separate them both. So they'll both travel with certain velocity v naught in this direction, no? Both of them will travel with certain velocity v naught in this direction. So final momentum of the system is m plus m into v naught. Understood? Okay. And if I apply conservation of momentum, initial momentum is equals to final momentum. Or mv plus m into 0 is nothing but 0 is equals to m plus m plus capital M plus capital M into v naught, or new velocity v naught is equals to mv by m plus m. Very and simple. Now the question is not asking the final velocity of this block. The question is what is the maximum height reached by this. See, at maximum height, okay, let me draw this block little bit lowered. Okay, little bit lower, but you will get the wrong idea that, okay, vy. Okay, at maximum height, what is the vertical velocity of the block? At maximum height, the vertical velocity of the block is equals to 0. Okay, vy is equals to 0 or 0 in vertical direction. But there will be some horizontal component of velocity, no, which is equals to v naught, because there is no force acting on this direction. Okay, so final kinetic energy. I'll just apply work energy theorem out here, or final kinetic energy. Okay, final kinetic energy is nothing but half m into v naught square plus half capital M into v naught square, because both are moving with the velocity v naught, no? And applying work energy theorem in the entire system. Final kinetic energy is this value. Okay, initial kinetic energy. Initial kinetic energy is nothing but the when the block was out here. Okay, when the block was out here, what is the value of kinetic energy? Half m v square. Oh, did this block have any kinetic energy? No. So final kinetic energy minus initial kinetic energy is equals to work done by all the forces. And what is the work done by gravity in climbing up to the maximum height, work done by gravity is equals to minus mgh. Okay, work done by all the forces. Work done by all forces. Okay, is equals to minus mgh. Okay, where h is the maximum height the body has been reached. Now, some of you might have questioned, so normal forces are doing work in these bodies. Okay, normal force in this question is an internal force. Internal force means although normal force from the frame of reference, from ground frame of reference, normal force is doing some work, but the negative work done by normal forces on this block would be cancelled out by the positive work by normal forces on this block, because both are moving in the same displacement in the horizontal direction. So normal forces is an internal force in this entire system. Understood? And I'm applying work energy theorem for the entire system. That's why only force doing work out here is nothing but gravity force. Okay, and out here normal force is nothing but perpendicular to the displacement. So out here normal force wouldn't be doing any work. Okay, so if I apply change in kinetic energy or half, okay, I'm taking V naught square common, m plus m. This value is nothing but this entire value, final kinetic energy minus initial kinetic energy is equals to work done by all the forces. Okay, so now let's substitute this V naught out here. Okay, or half into V naught square, mv by m plus m whole square into m plus m into capital M plus m, capital M plus m. Okay, minus half mv square is equals to minus mgh. Okay, out here if we cancel out this one and this square, okay, divided by m plus m. Okay, now what can I do? Now see, half m square v square divided by capital M plus small m. Okay, minus half mv square is equals to minus mgh. Now I need to find out the value of h. So I'll just solve this equation after. Okay, I just took half mv square from common from both these terms. Okay, and if I simplify this term, I can take LCM as m plus m. So if I take LCM as m plus m, okay, and minus 1 means I have to subtract this entire term out here, minus m minus m. So out here m and m get cancelled. Okay, minus m is equals to, I can cancel out this m, this minus and this minus will get cancelled. Okay, so out here I need to find out the value of h. H is equals to mv square, capital M v square divided by 2m plus m into g. This is the value. This is the maximum height the block has been reached. In this question, this is a frictionless surface. Okay, a ball started sliding out here and came out here on top of a slab. Now the slab has some friction. The top portion of the slab has some friction. What happened is, as the ball came out here, it will start dragging the slab with itself because the top of the slab has some friction, isn't it? So after some time, what will happen? The friction force will act and it will start to move the slab, and the ball will start to slow down because of friction. So after a certain while, both the ball, okay, and the slab will move with same velocity. Why? Because after the friction force has stopped working, the relative velocity of the ball with respect to slab should be zero, no? Because the friction force, the work of friction force is to oppose relative motion. So after the friction force has done all its work, the velocity of the ball and the velocity of the slab will be same. So out here, okay, as the ball reached out here, okay, it has some velocity. What was the velocity of the ball as it reached out here? If I apply work energy theorem, half mv square minus 0 square is equals to mgh. So if I apply half mv square as it rolled down the hill minus 0, which is the kinetic energy on top of the hill, is equals to work done by gravity. Are there any other forces? Yes, of course, normal forces is there, but the work done by normal forces is zero. Why? Because displacement is always perpendicular to the normal reaction force. So we'll get the velocity of the ball under root 2gh. So as the ball arrived out here, the velocity of the ball is nothing but under root of 2gh. Okay, now see. Now we need to find out v1. Okay, what is the velocity v1? Now see, between ball and the slab, okay, the friction is internal force. So can I apply conservation of momentum? Okay, initial momentum of the ball plus initial momentum of the slab is equals to final momentum of the ball plus final momentum of the slab. Why? Because no external force is acting on this ball slab system. So conservation of momentum, applying conservation of momentum between ball and the slab. Okay, mass of ball into velocity of ball under root of 2gh plus mass of slab into velocity of slab. Okay, initial velocity of ball and initial velocity of slab is equals to mass of ball into final velocity of ball plus mass of slab into final velocity of slab. So we get our final velocity as m into under root of 2gh by how much? Small m plus capital M. Okay, so both the ball and the slab will move with the same velocity. Now the question is asking find out the work done by friction force. Find the total work done by friction force. So if I apply work energy theorem out here, okay, final kinetic energy minus initial kinetic energy is equals to work done by friction force. So what is the final kinetic energy of the system? Half m plus m v1 square, okay, minus what is the initial kinetic energy of the system? Half small m v square. Okay, the initial kinetic energy of the slab is equals to 0. That's why there is no initial kinetic energy of the slab, is equals to work done by friction force. Work done by friction force. Okay, so out here I can simply write half m plus m into v1 square. What is v1? Okay, v1 is this value and the square of v1 is nothing but m square into 2gh divided by m plus capital M whole square. Okay, minus half m v square. What is v square? 2gh. So it is half m into 2gh is equals to work done by friction force. Okay, so let's eliminate this one. M plus m will get cancelled. Okay, okay. 2 out here, 2 out here, 2 out here, 2 out here, and 2 out here would get cancelled. So let me eliminate this one. Okay, if you take, acha, I have cancelled 2gh. I should not have cancelled gh. Okay, see, I, I mistakenly eliminated the g out here. Okay, now if you take mgh common from both of them, what will happen? Mgh is equals to m by m plus m minus 1 is equals to work done by friction force. Okay, mgh into m minus capital M by m plus m is equals to work done by friction force. Okay, so m and m would get cancelled, so it would be minus m by m plus m. So work done by friction force would be minus m into mgh. I'm just multiplying these values inside the bracket. Okay, so work done by friction force is this value, or work done by friction force is negative. Okay, now first I'll do the discussion in this process, then I'll go to the second part of the question. The first part of discussion is, why didn't I apply just half mv1 square minus half mv square is equals to work done by friction force on this block? Okay, why do I have to take the kinetic energy of this slab also? The friction force is an internal force, no? So if I take the kinetic energy of the slab, wouldn't both of them get cancelled? Because friction force is an internal force, no? So positive work done by friction force on this slab would be negative work done by friction force on this slab. Actually, no. Okay, what happens out here is, see, if the slab was joined to the was fixed to the plane, okay, that means the slab was fixed to the plane, the slab was not moving, then you could do that process. But out here what is happening is, the slab itself is moving, no? So the work done by friction force on the ball would not be same in magnitude of the work done by friction force on the slab. Okay, the displacement of the ball would be far greater than the displacement of the slab. Understood the first part of the question? Okay, although the friction force out here is an internal force, the work done by friction force on this ball would not be cancelled out by the work done by friction force on this slab. Understood? Because both of them will have different displacement. Okay, okay. Now the second part of the question. What happens if we change our frame of reference? Will this value get changed? See, work done, kinetic energy, these are all dependent upon frame of reference, no? But in this question, suppose I'm taking my frame of reference to this slab. Okay, so we'll solve the second part of the question right now. So out here, what we'll do is we'll solve our question from the frame of reference of this slab. So initially, when the ball came on the top of the slab, it had a velocity v. Finally, when the ball came to rest, see, from the frame of reference of the slab, finally even the slab was moving with v1, no? So what would be the final velocity of the ball with respect to the slab? It would be 0, isn't it? So final velocity of the slab would be 0 because our frame of reference is the slab. Okay, see, from the frame of reference of the slab, initially the ball came with under root of 2gh when the slab was not moving. Okay, finally when the ball stopped moving, it would be 0. Okay, so I can say final kinetic energy minus initial kinetic energy half m v square. What is v square? Under root of 2gh, or 2gh is equals to work done by all the forces on the slab. So work done by how much? Work done by friction force. Are there any other forces acting on this ball right now? Yes. See, when the ball came out here and it started dragging the slab, that means the slab has some acceleration because it started moving from zero velocity, no? From zero velocity to it had some velocity v1. So the slab has some acceleration, and our frame of reference is the slab. So our frame of reference has some acceleration, no? So if our frame of reference has some acceleration, there would be a pseudo force. Okay, so there would be some work done by pseudo force also. Now my question is, what is the pseudo force? Okay, see, to find out the pseudo force, first we need to find out the acceleration of the slab. Okay, see out here. Okay, now you have to find out the work done by pseudo force. To find out the work done by pseudo force, we need to find out the acceleration of this slab. So first we need to find out the acceleration of this slab. How do I find out the acceleration of this slab? What is the only force acting on this slab? The only force acting on this slab is equals to friction force. So friction force is equals to mass of the slab into acceleration of the slab, no? Okay, or acceleration of the slab is equals to friction force divided by mass of the slab. Okay, so this friction force or this pseudo force, okay, pseudo force is nothing but mass of the body into acceleration of the frame of reference in opposite direction. What is the acceleration of frame of reference? Friction force divided by mass of the slab. Acceleration of the frame of reference is nothing but friction force divided by mass of the slab. Fair and fine. Okay. Problem is, what is work done by pseudo force? Work done by pseudo force is nothing but friction. Not work done by friction force. Work done by pseudo force. Work done by pseudo force on this block is nothing but the pseudo force itself. Okay, pseudo force is m into friction force divided by capital M, and work done is nothing but force into displacement into L. Okay, but L is the length traveled by the ball. Okay, see, length traveled by the ball before stopping. Understood the approach? I'm repeating once again. Since this slab itself has an acceleration, there would be a pseudo force on this ball. Okay, to find out the pseudo force is nothing but mass of the ball into acceleration of the slab. In order to find out the acceleration, we need to draw the free body diagram of the slab. Okay, what is the only driving force of this slab? The friction force in this direction, isn't it? The ball is exerting friction force on the slab in this direction. So friction force is equals to mass of the slab into acceleration of the slab. But acceleration of the slab is equals to friction force divided by m. So therefore pseudo force would be mass of the ball into acceleration of the slab. The work done by pseudo force would be pseudo force into length traveled. Okay, length traveled before stopping, which is equals to L. Okay, fair and fine. Now see, what is this friction force into L? This friction force into L is nothing but work done by friction force, no? Work done by friction force, isn't it? See, what is the work done by friction force? Friction force into L. Okay, so if I take minus half m into 2gh is equals to work done by friction force plus work done by pseudo force, which is nothing but work done by friction force into m by capital M. See, work done by friction force into small m by capital M. Now one more thing out here. Okay, the work done by pseudo force is negative. Sorry, work done by friction force is negative. Okay, and the work done by pseudo force is also negative. So both out here would be multiplied by minus. Why is work done by pseudo force is negative? Because pseudo force is acting on this direction and displacement is happening in this direction. Why is the work done by friction force negative? Friction force is acting on this direction, ball is displaced on this direction. Okay, I'm only considering in this equation, I'm only considering the free body diagram of this ball. Okay, now see, this minus and this minus would get cancelled into positive. These two and these two I'm getting cancelled, or mgh is equals to work done by friction force. I'm taking this common. Okay, I'm taking work done by friction force common from both this term into 1 plus small m by capital M. Okay, or work done by friction force is nothing but mgh is equals to work done by friction force. Let me elongate this one, capital M plus small m divided by capital M. I just took the LCM. Or if I take this entire term to the left hand side, what will it be? Work done by friction force is nothing but capital M small m GH by M plus M. Okay, out here it is turning out to be, out here the work done by friction force, I'm getting only the magnitude. Understood? So this was our question of 164.